Hello everybody. We're going to take a look at Unit 5.2F at WAMAP, which is volume. It's in the area, volume, and temperature section. And we're going to look at the volume of a rectangular solid. Okay. If you want to have an overview, there are some links here to Khan Academy to study this topic a little bit. There are two videos in WAMAP, of course, and then we've got links to the GED formula sheet and the WAMAP formula sheet, which you may need if you don't know how to calculate the volume of a rectangular prism. And they say solid here. I guess we're calculating this is the volume of an aquarium, which is not truly solid. That would be more like a brick. But let's take a look at the formula sheet and see what it says. So we've been doing linear and area, linear measure and square measure, which is two-dimensional. Linear measure is one-dimensional. And so now we're going to go to the next level, which is volume, which is cubic measure. That's x to the third power. So if we have a rectangular prism, so this shows us surface area and volume. So when you're using the GED formula sheet, just remember surface area is if you were to wrap this in wrapping paper, how much wrapping paper would it take? And so this is three separate area calculations. So this is similar to doing the area of a square or the area of a rectangle, but on steroids. You've got six rectangles coming together to make that prism, right? So it's like a cube. So you've got six sides. So we've got 2 times 2 times 2. And that surface area, we're looking at volume, which is a lot easier. It's length times width times height. So when you want to figure out the volume of a rectangular prism, it's length times width times height. And let's go down to the next sheet and see what the WAMAP worksheet says. Volume equals length times width times height. Okay, so these are their volume formulas where there's a V, and then I don't even know, WAMAP I guess doesn't do surface area, but if you're taking the GED, you may need to use those surface area formulas if they ask you what for those numbers. So these are how to calculate the surface area of those shapes. Okay. So if you are planning to take the GED, just go ahead and try to familiarize yourself with these terms. And if you have questions, don't hesitate to ask. Okay, so let's figure the volume of this. So it's always a good idea to look at the notes around here. This says figure is not drawn to scale. So it's kind of obvious that if this is 3 meters, this cannot be 8 meters, and 19 meters would be much longer. So they want you to develop your abstract thinking. We're going to focus on the numbers here and not on the picture. This 19 meters is like 60 feet. So that tank is not that big, I'm sure. But for the purpose of finding the volume, we know that V is equal to L times W times H, LWH. And so it's kind of arbitrary what's what here, but in the classical sense, H is here, the 3, and L would be 19, and M, the 8, would be the width. Let's see if I can show you what I'm looking at. Nope. How about now? Yes. Okay. So you could set it up this way. Volume equals length times width times height. So we're just going to multiply these three numbers together because my calculator's acting up. I'm going to just do it on the calculator here. So 8 and then an asterisk, which is the multiplication symbol, also uppercase 8, times 19 times 3. And because it's multiplication, it doesn't matter what order. We've just got the one operation. So if we hit enter, that should give us our answer, 456. So our volume here would be 456 meters cubed. So we are working in 3 dimensions now. So our volume, that's why we call it volume. The volume is, we have this cube here. So 456 meters cubed, or 456 cubic meters. And that just tells everyone that the units here are measured in 3 dimensions. Volume is like area with one more dimension. Area is usually just length and width, but we've also added height. So 8 times 19 would be the area of one face, like the top face, and then you just multiply that by the height, and it increases that area by that much. Okay, so 456 cubic meters is our answer. Let's see if we can put that in. 456. And they have the unit here already, meters cubed. So you can just hit the submit with your fingers crossed. Okay. So this box problem is really similar. It's almost the same numbers even, 8 and 3 and 16. So it's just going to be like 72 less than this. Anyway, go ahead and try to work that on your own. And if you have any questions, just click message instructor and I'll try to get back to you within 24 hours. Good luck.